Transportation. What does that word mean to you? Consider the fact that at some point in time, the only known method of transportation was walking or horseback. Granted, this was a long time ago, but how do we get from that to where we are today? Innovation. Cycling through the years, great landmarks have been made due to innovation. Planes, trains, even rocket ships. But how about the most influential of all? The automobile. A personalized method of accessible transportation, most commonly propelled using an internal combustion engine, electric motor, or both. Of course, gas engines have dominated the market for nearly a century as the technology for EVs were behind in both speed and range. But times are changing. Electric vehicles' performance have been proved to be equal, if not greater than that of gasoline-based predecessors, but at a cost. The average price of a modern electric vehicle is $30,000 to $40,000. Why is that? The main factors are due to the price of batteries and manufacturing, but nearly 10% of that cost comes from the electric motors themselves, most of which are either permanent magnet or induction motors. Both are very effective, but designed using rare earth metals that are costly and environmentally unstable to mine. However, another type of motor exists. One that has been designed for higher performance without the need of harmful rare earth metals. The switched reluctance motor. Never before seen in a vehicle, this motor has the potential to become the prime choice for the traction motor in all electric vehicles. So why don't we put it to the test?
We tasked ourselves in designing an electric powertrain for a 2016 Chevrolet Camaro using a switched reluctance motor as the main propulsion component. Our work and designs this year can be further developed by graduate students researching in this field. This project required four main features. First, a control board, which acts as the main controller in the vehicle, managing CAN systems, high-side power switching, and any inputs and outputs. This was designed using LTM to first design the schematic and then create the PCB design. The second phase of our design was a full vehicle harness showing the component pinouts, connectors, fuse box layout, etc. It overall captured the full high and low voltage systems in the vehicle, and it was all designed using AutoCAD Electrical. Third is controls and modeling, which was done in MATLAB Simulink. This allowed us to run test simulations based on our design and also allowed us to compare performance metrics against other parameters to prove our feasibility. Lastly is a vehicle safety, which has been implemented for high voltage systems in emergency shutdown situations.
This project has far-reaching applications for the automotive industry. Given that switched reluctance motors are high-performance electric motors, an application of them in automobiles allows for a variety of classes of electric motors to be manufactured and produced by the same company. Just as there is a daily commuter car with a 4-cylinder engine and a muscle car with a V8 manufactured by the same company, a variety of electric motors on the market will help consumers find the motor that meets their needs while still being environmentally conscious when making the jump from combustion engines to electric motors. Applying switched reluctance motors in automobiles allows for more sustainable practices in the manufacturing and production process, as well as reinforcing sustainable behavior in automotive consumers. The benefits of not requiring rare earth metals to manufacture a motor are twofold. First, using commonly accessible metallic resources means sourcing materials that are easier and more environmentally friendly to extract. Second, using those materials leads to cheaper manufacturing of the motor, which then can translate to cutting the sale price, enticing more consumers to purchase electric vehicles and cut down their emissions when they hit the road. To summarize the outcome of this entire project in one sentence, applying an SRM to a performance vehicle has shown comparable driving capabilities and given proof of concept to a future where electric vehicles are even more justifiable as the norm.